Hello and welcome to this video on a new generation of satellites that are helping authorities track methane emissions. Methane is a powerful greenhouse gas that contributes to climate change, and it's important to understand where it's coming from so we can take steps to reduce emissions. One way we're doing this is by using a new generation of satellites that are equipped with advanced sensors. These satellites can measure methane levels in the atmosphere with unprecedented precision, and they're providing us with detailed information on where methane is being emitted. One example of this is the European Space Agency TROPOMI satellite, which is equipped with a sensor that can detect methane with a precision of 0.2 parts per billion. This is an incredible improvement over previous technology, which could only detect methane at levels of around 2 parts per billion. Another example is NASA's satellite, which is equipped with a sensor that is able to detect methane leaks, which is not possible with traditional ground-based monitoring methods. These new satellites are helping us to identify major sources of methane emissions, such as landfills, oil and gas operations, and livestock farming. This information is crucial for policymakers and industry leaders as they work to develop strategies to reduce methane emissions and slow the pace of climate change. In addition to the examples of the European Space Agency TROPOMI satellite and NASA's satellite, there are several other satellites that are also helping to track methane emissions. For example, the Japanese Greenhouse Gases Observing Satellite GOSAT and the Canadian Space Agency SCISAT satellite. These satellites use different technologies to detect methane, such as infrared spectroscopy and laser absorption spectroscopy. Each technology has its own advantages and limitations, but together they provide a comprehensive picture of methane emissions around the world. One important application of this satellite data is in monitoring methane leaks from oil and gas operations. Methane is the primary component of natural gas, and it's often released during the extraction, transportation, and processing of oil and gas. These leaks can be difficult to detect from the ground, but satellites can detect them from space. This information is helping regulators and industry to identify and fix leaks, which can save companies money and reduce greenhouse gas emissions. For example, in the US, the Environmental Protection Agency methane rule requires oil and gas companies to monitor and report their methane emissions, and the satellite data is being used to verify the accuracy of these reports. Another important application of satellite data is in monitoring methane emissions from wetlands, rice paddies, and other natural sources. These emissions are a significant contributor to the overall methane budget, and understanding their variability is crucial for predicting future changes in methane concentrations. Satellites are also helping to monitor emissions from livestock, as well as from landfills and waste management sites. By understanding where these emissions are coming from, we can develop targeted strategies to reduce them. In addition to monitoring methane emissions, these satellites are also providing valuable information on other greenhouse gases such as carbon dioxide and nitrous oxide. This information is helping us to understand the overall carbon cycle and the complex interactions between different greenhouse gases. One of the challenges in using satellite data to track methane emissions is accounting for the effects of weather and atmospheric conditions. Methane concentrations can vary depending on factors such as temperature, humidity, and atmospheric circulation patterns. Satellites can provide data on methane concentrations, but ground-based measurements and models are needed to understand the underlying processes that are driving these variations. Another challenge is that methane emissions are not evenly distributed around the globe, so satellites need to be able to observe different regions with different levels of emissions. This is why it's important to have a fleet of satellites in orbit, each with different sensors and capabilities. Overall, the new generation of satellites is a game changer in the fight against climate change, providing us with the data we need to make informed decisions about how to reduce methane emissions. With the help of these satellites, we can better understand the sources of methane emissions and take action to reduce them. In conclusion, the use of satellites to track methane emissions is a crucial step in the fight against climate change. By providing us with detailed information on where methane is being emitted, satellites are helping us to identify major sources of emissions and develop strategies to reduce them. The satellite data is also helping to verify the accuracy of industry reports and monitor emissions from a variety of sources. With the continued development and launch of new satellites, we can expect even more accurate and comprehensive data in the future. This information is crucial for policymakers, industry leaders, and scientists as we work to reduce methane emissions and slow the pace of climate change. Thank you for tuning into the Orbital Insights, where we explore all things space. Let us know what you think about these satellites in the comments below. Until next time.